Welcome to Quick MCAT Lessons, where I try to explain MCAT topics in 10 minutes or less. Today, we're going to be finishing up our unit on enzymes with some practice questions. So let's get started. Number 1. Enzymes A. Make a reaction thermodynamically favorable. B. Help in reaching the equilibrium faster. C. Increase the amount of product formed. Or D. Make the forward reaction faster than the reverse reaction. And the answer here is B. They help in reaching the equilibrium faster. Recall that they don't change the reaction, they don't change the thermodynamics of the reaction, they just help it occur faster. That's all. Number 2. A ribozyme is a protein-based enzyme, B. Nucleic acid-based enzyme, C. DNA-based enzyme, or D. Lipid-based enzyme. And the answer is B, because ribozymes are of RNA molecules, which is a nucleic acid, so it is a nucleic acid-based enzyme. Number 3. Dehydrogenase is an example of which type of enzyme? And it's an oxidoreductase. Number 4. What type of enzyme moves functional groups from one molecule to another? And this is a transferase. Number 5. Exonucleases are examples of which types of enzymes? And the answer here is hydrolases. Recall that hydrolases are often named after their substrate, and we have hydrolases like phosphatase, protease, peptidase, nucleases, and lipases are all hydrolases. Number 7. Which of these enzymes are lyases? A. Decarboxylases, B. Dehydrogenases, C. Kinases, or D. Endonucleases. The answer is decarboxylases, because decarboxylases remove carbon dioxide from the substrate, so decarboxylase is a lyase. But even if you didn't know what a decarboxylase is, you can still figure it out, because we know that dehydrogenases are oxidoreductases, kinases are transferases, and endonucleases are hydrolases. Number 7. Which type of enzyme helps in the reaction of glucose 6-phosphate to fructose 6-phosphate? And here the answer is isomerases. This is because we're not adding or removing any atoms, we're just changing some things around, and this is an isomerase. Number 8. An organic, non-protein component that binds with an enzyme to help in its action is known as A. a cofactor, B. a coenzyme, C. an apoenzyme, or D. a holoenzyme. And the answer here is coenzyme. You should have narrowed down to cofactor or coenzyme based on the non-protein component. And then it says organic, which is coenzyme. If it said inorganic, then it'd be cofactor. Number 9. Which of these is explained with the help of Michaelis-Menten saturation curve? A. Relation between substrate concentration and product concentration. B. Relation between substrate concentration and reaction rate. C. Relation between product concentration and enzyme concentration. Or D. Relation between enzyme concentration and reaction rate. And this is just a recall question. If you know about the graph on the Michaelis-Menten curve, you should know that the y-axis is V, which is reaction rate, and the x-axis is substrate concentration. Number 10. The substrate concentration at which 50% of the enzymes in a system are saturated with substrate is A. Vmax, B. half Vmax, C. Km, or D. Kcat. And the answer here is Km. Km is a mathematical value which is equal to the substrate concentration when a reaction is half its maximum rate. Number 11. Which of the following is associated with high binding affinity? A. Km is increased, B. Km is decreased, C. Vmax is low, or D. Vmax is high. The answer is Km is decreased. Less Km means less substrate is needed to achieve half the Vmax, which is possible when the binding affinity is high. So when the Km value decreases, the binding affinity increases. So option B is correct. Number 12. For a given enzyme, Km is 2 molar and Vmax is 200 molar per second. What will be the rate of the reaction catalyzed by the enzyme when substrate concentration is 5 molar? A. 100 molar per second, B. 155.55 molar per second, C. 142.85 molar per second, or D. 94.73 molars per second. And so here you should remember the equation for reaction rate, which is V is equal to V max multiplied by substrate concentration divided by Km plus substrate concentration. And so V max is 200, substrate concentration is 5, so the numerator is 1,000. Km is 2, substrate concentration is still 5, so the denominator is 7. And if we divide 1,000 by 7, we get 142. You can do this in your head also. You know that 7 times 100 is 700. And now you have 300 remaining. You know that 280 is close to 300, and 40 times 7 is 280. So you add a 4, so you know it's at least over 140. And then you know if you add 3 sevens, making it 143, you get 21. And so 280 plus 21 is 301. 301 plus 700 is 1001. And this tells us that 1,000 divided by 7 is just under 143. So choice C would be correct, 142.85 moles per second. Question 13. Which type of inhibition does Km increase while Vmax remains unchanged? Now, there's only one type of inhibition where Vmax remains unchanged. That is competitive inhibition. Every other inhibition, Vmax decreases because enzymes are unable to be used to their full potential. Some are getting changed, some are getting something else, but if it's competitive, then the substrate can overcome this, and so Vmax remains unchanged, but you need more substrate, so your Km increases. Number 14. Which of these is seen in a case where an inhibitor acts on an enzyme by uncompetitive inhibition? A. Vmax decreases and Km decreases. B. Vmax decreases and Km remains unchanged. C. Vmax remains unchanged and Km increases. Or D. Vmax increases and Km decreases. Now, in uncompetitive inhibition, if you just remember the Lineweaver-Burke plot, it's much easier. You know that it's a parallel line and a parallel line. So if you want a parallel line, then both must decrease. If one decreases and one doesn't, or one increases, one decreases, then you'll get intersecting somewhere. So if you want a parallel line, both have to decrease, and so the answer is A. Vmax decreases and Km decreases. Question 15. An inhibitor that can bind to the enzyme and enzyme substrate complex with unequal affinity is called a? That is a mixed inhibitor. Question 16. Which of the following is an irreversible inhibitor? A. Competitive inhibitor. B. Suicide inhibitor. C. Non-competitive inhibitor. Or D. Mixed inhibitor. I'm sure you could tell from the name that suicide inhibitors are irreversible inhibitors. This is because the inhibitors become covalently bound to the enzyme during the inhibition, and they cannot be removed, so they essentially undergo suicide. Question 17. Which of these is not a method of enzymatic regulation? A. Allosteric interactions. B. Covalent modification. C. Proteolytic cleavage. Or D. Misfolding. And the answer is D. Misfolding, because misfolding refers to the disruption in the tertiary structure of enzymes. This causes the loss of function, so it's not used for the regulation of enzymes. Question 20. Phosphorylation of an enzyme regulates the enzyme by which of these methods? A. Allosteric interactions. B. Covalent modification. C. Competitive inhibition. Or D. Proteolytic cleavage. And I hope you remember that phosphorylation, acetylation, all these things are covalent modifications. So option B is correct. Number 19. Enzymes that are active until a part of them are cleaved off are? And the answer is zymogens. Number 20. Breakdown of pyruvate into acetaldehyde and carbon dioxide is done by which type of enzyme? A lyase, oxidoreductase, transferase, or ligase? Well, here you should be able to narrow it down. We know that ligases join together because you can think of DNA ligase. We know that that joins two things together. So it's not ligase, it's not transferase because that just moves something around. And it's not oxidoreductase either because that just reduces or oxidizes something. But what we're doing is we're breaking pyruvate into two compounds, into acetaldehyde and carbon dioxide. So this must be a lyase. Number 21. Which of these is not true according to the induced fit model? A substrate has a shape that fits exactly into the active site of the enzyme. B, substrates and enzymes have attractive interactions. C, the enzyme and substrate are distorted into a transition state conformation. Or D, this model is seen in a majority of enzymes. So this model is majorly seen, and it is distorted into a transition state conformation, and they have attractive interactions. But what is wrong is that it does not have a shape that fits exactly into the active site of the enzyme. So A is the one that is wrong. So A is correct for this question. Number 22. When a cofactor binds to the inactive protein portion of an enzyme, what is formed? The answer here is a hollow enzyme is formed. Number 23. What is the maximum reaction velocity for an enzyme whose concentration is 3 molar and whose turnover rate is 100 per second? Is it A, 0.03 molars per second, B, 33.33 molar per second, C, 300 molar per second, or D, 500 molar per second? And now you could go about this two ways. You could use the formula for kcat and you could do all this multiplication and remember the formula, or you could just look at the units. We want the answer in molar per second, and we are given molar and we are given a rate that's in per seconds to s to the negative 1. So this tells us that we just need to multiply them together and we'll get molar per seconds. And so 3 times 100 is 300, and so the answer is 300 mole per second. Number 24. Which of the following statements about enzyme kinetics is false? A, an increase in the substrate concentration at constant enzyme concentration leads to proportional increases in the rate of the reaction. B, most enzymes operating in the human body work best at a temperature of 37 degrees. C, an enzyme substrate complex can either form a product or dissociate back into the enzyme and substrate. Or D, maximal activity of many human enzymes occurs around pH 7.4. And the answer is A, because we know that it doesn't go linear. It goes linear when there's less substrate, but when there's more substrate and it gets closer to Vmax, the reaction rate slows down. Number 25. Which of the following factors determines an enzyme specificity? A, the three-dimensional shape of the active site. B, the Michaelis constant. C, the type of cofactor required for the enzyme to be active. Or D, the prosthetic group on the enzyme. The answer here is the three-dimensional shape of the active site. Number 26. Consider a biochemical reaction A goes to B, which is catalyzed by AB dehydrogenase. Which of the following statements is true? A, the reaction will proceed until the enzyme concentration decreases. B, the reaction will be most favorable at 0 degrees Celsius. C, a component of the enzyme is transferred from A to B. Or D, the free energy change delta G of the catalyzed reaction is the same as for the uncatalyzed reaction. So first, it's saying that the enzyme here is a dehydrogenase. So this means it's an oxidoreductase. So it can't be C because we're not transferring anything because it's not a transferase. So it's not C. Now for A and B, the reaction will proceed until the enzyme concentration decreases. Will the enzyme concentration stay the same in the reactants and products? It doesn't get used up in the reaction at all, so it's not A. And B, this is a biochemical reaction, so it will most likely not be most favorable at 0 degrees Celsius. Probably it will be more favorable at 37 degrees Celsius. That leaves D. The free energy change in delta G of the catalyzed reaction is the same as for the uncatalyzed reaction, and this is true because enzymes do not affect the thermodynamics. That's all for today. See you next time.